Most of us see gigantic insects and politely head in the other direction. Other, more adventurous types, like behavioral neuroscientist and National Geographic explorer Verner Bingman, are apt to crawl around the Costa Rica rainforest in the dark, trying to catch huge whip spiders.
We're looking for whip spiders tonight because they come back each night faithfully to the same little refuge site in this large tree that you've seen a little bit of. They have a remarkable navigational ability.
Verner is running an experiment to better understand how these whip spiders navigate. But first, he needs to catch them.
If you don't get it, they usually disappear into the tree crevices and that animal is lost for the night.
Quick preface on whip spiders. While there are over 150 species of whip spiders, they actually aren't spiders at all. Just a close relative in the same class of species, Arachnida. Arachnids typically have 8 legs. However, in some species, like the whip spider, 2 of the legs have evolved to perform sensory functions. These whip-like appendages, called antenniform legs, are long and thin. Whip spiders also have pincher-like appendages, which they tend to use when scientists try to catch them.
They're very aggressive. They can draw blood. And you got to tough it. Once you have the animal, you're not going to drop it just because it's pinching you. We're going to take this animal right now, and we're going to put this radio transmitter on. We're going to take it about 10 meters away to a place it's never been to before and see how successful it is navigating back to the tree where we found it. You can generally see them progressively moving closer to the home tree over a series of days.
These temporary radio transmitters broadcast location data and will fall off when the whip spider sheds its exoskeleton.
Well, guys, if you think there's any doubt that they don't come back with the transmitters, here's a guy that was away 10 meters away, and he's pretty much at exactly the same spot that we saw it when we captured it. So I think it's important to note that not only does this animal get back to the home tree, it's actually in almost the exact spot where we found it. It becomes reminiscent of the kinds of things that homing pigeons do and sea turtles do. What sensory information are they using? Are they smelling their way back? Are they seeing their way back? Are they hearing their way back? So for some of the animals that we've captured, we're going to cover the tips of their antenniform legs with nail polish.
The temporary nail polish blocks the sensory abilities of the antenniform. This aids in the process of elimination, helping Verner to gauge the extent that whip spiders rely on their antenniform, their 8 eyes, or something else for navigation. So, do the spiders with painted nails make it home?
And the question is, do you get back? They can't.
Nope.
It implies that smell and touch information is crucial for these animals to figure out how they're going to get their way back home. It's really, really exciting to look at how a true kind of navigational system can evolve with a relatively simple nervous system that these guys have.